The Neko Light Orchestra, the musical collective, had the idea of doing a marathon. The Neko Light project is really interesting because there are so many musicians on stage, up to 13. So the goal was to recreate the musicians' stage positions to give a sense of depth of field, which is really difficult to do on a stereo system as we can't get the sensation of distance from the source, though there are some ways that all the sound engineers will know. I wanted to work in immersive, but we could go one better and use WFS. I had no idea that it would be possible. For me, it was almost utopian. So we still had to define the number of sound sources that were going to enable us to do real WFS. As those who are interested in this technology will know, you need a certain number of speakers in order to create a credible experience. So we tried using 7 sources. Perhaps more would have been better, but nevertheless, it worked. I was confident from the offset. I even went out and bought the speakers in the week as I wanted to reproduce the experience and prepare the way ahead. Regarding the sound system, I used Karas in 7 clusters of 4 attached to a bridge in front of the stage, as well as Kivas in 7 stacks of 2 stacked on the stage. The Kiva stacks, of course, were on the same axes as the Kara clusters. For the mics and consoles, I used 2 Rio 3224Ds, a patch with 60 ins and a CL5. The appeal of the CL5, of course, being the Dante network, which allows us to interface the SPAT Revolution on the MacBook Pro with a virtual Dante sound card. Using the direct outs, I sent nearly all the sources to the SPAT Revolution, excluding the more complex instruments that require several mics, such as the piano, the harp, or even the strings, on which I always have a DPA and a pickup. So the SPAT having 50 audio channels, with SPATIAL engine itself generating 7 more that were attributed to each of the Kara clusters or Kiva stacks. The audio paths of the Dante and the SPAT Revolution passed through the Rio and hit the LA racks in AES. The appeal of the SPAT Revolution is to recreate a dimension. It's capable of generating in particular the reverb linked to that space. This is something we can't do in a traditional concert tools. The concept is compatible with several audio interfaces. It works with Mac's core audio engine, so we can plug that into whatever we like, be it Dante, DigiGrid, or whatever. So we can install a small setup with ease. In about an hour, we can do what we want. I'm not suggesting that we can easily exhaust all of its possibilities, because obviously there are many parameters, but still, after 1 hour, we can create a setup that works. I have to say, I couldn't believe it. Straight away, the sensation is incredible, because we can make the sound sources all but disappear. Obviously, we're used to hearing the sound coming from the speakers, which is still the case, of course. This isn't magic. However, the speakers themselves disappear behind the sound field, that famous synthesized sound field. It's no longer the console doing the mixing or the summation, it's the SPAT. And the SPAT doesn't just do left-right summation, the SPAT does a virtual summation in a virtual space. Perhaps it's that gives so much naturalness to the sources. That's the goal, in fact, to ensure that people are moved by the artist's emotions, and above all, to ensure that instead of having 15 or 20% of the audience in the centre with good seats, you know what it's like. Here, I was walking about earlier, and I'm almost tempted to say that we have 100%. Perhaps I'm exaggerating a little to say that 100% of the audience zone is good, but I really have the impression that we're able to respect the image that we want to portray, no matter where we are, both in terms of depth and breadth. And that's really incredible, because I don't know of anything else that would be capable of doing that on such a large audience zone. So after all these hours of work, what I felt in the Flux studios, or at home even, I also felt here. Better even, inevitably. We don't have the same sound system. It's just incredible. I think that we go beyond that which we can do with stereo, or other known systems. We go way beyond. It's gonna be tough to go back.
Here we are live, the fourth week delivering those webinars in a row. It's our fourth on five, another one coming up next week. Good day, everyone. Welcome, and thank you for joining this webinar. On today's here, I'm actually streaming live from Montreal. I'm in the Flux Immersive Studio in Montreal. Great to be seeing you. For the ones that are back, thank you for joining us again. For the ones that are new to these webinars, well, thanks for joining. Thanks for coming and coming to enjoy a little hour of conversations about some new features. Want to say hello to everyone that joined. It is 12 o'clock here in Montreal. It is we've got the West Coast that's waking up. We've got Central Europe that's actually just wrapping up their day and going for dinner soon. And well, thanks for Asia and the far east. Well, for me, east anyway, or west. It depends. Whatever. The far part. If you are joining and it's late in the night, I've been saying this every single week. Sorry if we didn't make 2 streams and today we're making only 1. So if you are up very late to join us, we really appreciate that. So yes, again, thank you for joining. Today's subject will be about, new panning techniques and spatial technologies that we're actually going to be bringing up as we're working on this major release. There is a very exciting subject in the spatial technologies, which a lot have been, waiting for. We're going to be talking about this today. So anyway, I'm, really looking forward to dive deep with you guys. We have on the actual chat right now a bunch of moderators. Yes, my friends from Flux in France are actually all online. Nicolas, Arsène, maybe Jean-Loup is there, maybe Felix, Gaël, even our lead developer actually likes to, be online and watch what's going on. So the point is that if there are any questions that comes up, feel free to ask them in the chat and they will get answered, as they are popping up. Chances are that they'll put them aside as well. And I will be kind of covering those, as we go along. We'll kind of bring, not going to say the most important questions, but the questions that we believe is kind of, very, applicable to the wider audience. But feel free to obviously ask questions. We'll have a Q&A period at the end. And yeah. Without further say, let's get diving into this interesting subject on our 4th webinar this week. As I said already. So today is going to be about the new panning and spatial technology upcoming, with our 2011 release preview, basically, just previewing a bunch of features. That's what we've been doing on the different weeks. And what that major release is all about, it's for us a huge leap in power and performance, in the sense that, we've been working very hard of chasing, improving the stability, hardening with all OS. As you know, right, OS comes in every day. Well, probably heard about Big Sur on the Mac OS that came out. So, it's obviously it's that chasing of making sure that, we're rock solid on various hardware, being OS, and for that matter of fact, audio interfaces as well. It is our official Catalina and Apple notarization support as well. But one very interesting one that our lead developer and our development team has worked on is this new multi-core parallel processing algorithm to take, basically, to kind of take as much of your core, your resource of your computer, and be as efficient as possible to process larger sessions than ever and at higher sample rate. Very proud of this one. There's actually some tuning option as well to tune it, but it is, being introduced. And there's a long list of things, and the point is not to, reveal and go on every single, a new feature that are involved there. But the other important one was actually, a new built-in reporting tools. Basically, you've seen those from people where, you're collecting data and bring it to the software development team. But that's what we've got as well. Again, plan is to make, the software as robust as possible. So new reporting tools, for a developer for any error codes, issues related to a specific computer, for example. Those are kind of the big lines of this major release, but there's obviously more than that. And, what it is obviously, packs of features, loads of them. We've been covering them every week. We've actually covered this, on the November 5th presentation where we start to talk about ease of configuration, how we've brought the system wizard, the setup wizard, I should say. For example, how we're bringing Pro Tools track templates, Revolution. If you haven't heard about this one, this is a complete script package for Reaper to make it, kind of work end to end with SPAT Revolution for creating immersive sessions. For someone that's new into immersive and is familiar or not with Reaper, it's just a great way to dive in. Reaper's large bus count is amazing for that. So that was that first session. And then, we kind of went on the second week and talked about speaker arrangement. And speaker arrangement had to do with importing and exporting, data. Something that we do now, we import from simulation software, being the D&B AriCalc software, Adamson, Nexo, raw data from Excel sheets, ease data, and we'll be adding some as time goes. But the point was actually to facilitate creating speaker arrangements. And on this session, we went on and talked about some of the rules, some of the things to know, because SPAT offers a lot of flexibility as far as choosing panning methods, using multiple rooms for various, creative intentions. But, it does come with some little rules as far as you can't just put speakers anywhere and use any panning. So we've covered that a bit. And we will be talking about this today a bit, just kind of reviewing this very shortly, as today the subject has to do with spatial technologies and panning methods, which is a primary. There is a little portion on acoustic simulation presets, which I will kind of review briefly. I kind of threw it in that bundle. It's a very short aspect, but it's actually a bunch of presets for acoustic simulation. And that will be today. And then getting ready for the last week. I'm going to miss you guys, actually. No, it's not going to be our last one. We'll be doing some more. But the last of this series of 5 webinars, and the last one will be about the complete OSC refactoring we actually did on, in our OSC connections, facilitating, the integration of third-party devices, creating OSC presets, OSC transformation, scaling, and that actually will cover as well an initiative of a common grammar, industry grammar called ADM OSC. And I'm not going to dig into this right now, but next week is going to be a very interesting subject as well. I'm looking forward to it as well. I've been looking forward to any of those sessions. But let's get back to our subject of the day. So today we're going to be talking about these points, acoustic simulation presets and management. That was partially there, and we've actually kind of finished this up. And I'm going to be digging on this portion. Then we'll talk about panning methods. New panning methods available in the long list of panning methods that we have. Layer-based amplitude panning, so we're still in the in the vector base, but here on an approach basically of anyway, I'll dig into it a bit later. So the layer-based amplitude panning, dual band VBAP. So it is the vector base, but it's kind of an hybrid of 2 panning methods, and we'll talk about the advantages of using dual band VBAP. And another quick one, which we won't cover too much today. Ideally, I would actually be streaming you some audio, and it's a great thing to do on YouTube. We could have actually done that, but I wanted to take enough time, so we will cover this in probably an upcoming webinar specific on binaural. So binaural without actually audio in your ears wouldn't probably make sense. So what we're basically adding, and I'm just going to briefly talk about it, is 3 new binaural techniques. One is called near field. So, where HRTF traditional are taking at some, further away distance, the near field is to give you that near field effect when you're using binaural technology. So near field is one option, and 2 other options that do not rely on HRTF, and it is what we call the spherical head, just basically a sphere that becomes the reference for creating that synthesis. And the last one, but not least, is the snowman model. And the snowman is basically a head and some shoulders, right, for creating these HRTF. The people that are familiar with binaural a bit will understand what's going on there. But we'll be covering this at another time, a later time. I might just show it to you quickly later on if we have time, depending. But as some of you know me, I can go on and talk. So maybe we won't get there. And then the nice one, the exciting one. Well, they're all exciting, as I said. New spatial technologies, part of the live production package. It is an option. It is not part of the actual standard license, and we'll talk about this another point. Wave field synthesis, WFS, now part of SPAT Revolution. So as an option, as an actual panning techniques, WFS can be used. It's a relaxed WFS, which we'll talk about, and we'll talk as well about the fact that it can be combined with other strategies. You're not obliged or forced to use only that strategy. That has some realities that comes with it. So you guys are ready? Am I ready? Hugo, are you ready? I guess I'm ready. 12:15 here in Montreal. Let's see if I can do this and not go on for hours. Okay, so the acoustic simulation aspect, this one will be fairly quick to talk about. So basically, you know, we've always had this multi-room concept, which you may be familiar with, you know, if you've been around, and if not, well, basically multiple virtual environments. But these virtual environments, these rooms that we call them, this multi-room concept, actually means as well an acoustic simulation in all these environments. That can actually bring a lot of creativity, moving source from a space to another. Without getting into the details, we did not have really presets for those. So it was basically DIY, you know, get started on the parameters of the Reverb engine. So we've actually brought in 23 new Reverb presets. These are the presets that are coming from the IRCAM SPAT, and IRCAM SPAT, which is the legacy of SPAT Revolution. This is why we're here to talk about SPAT Revolution today. So all these presets were brought in, and then we actually have some of the IRCAM Verb. If some of you are familiar with the IRCAM Verb plugin, part of our catalog, which comes from the IRCAM Reverb, we actually brought some of those plugins. So total 23 new presets. Yay. Presets, starting points, we'll see them when we get them. And then the other thing that we've cleaned up and kind of, you know, doing for feature update is the ability to save new presets. Yeah, we didn't have that fully finished, but mainly to export and import presets as well. So creating some presets, exporting them, importing them back another project. This is the Reverb preset file that we'll be looking at, where you can basically save a single preset or all the actual presets, okay? Important to know as we're talking about the Reverb engine, I've put a note there, you know, changing the Reverb presets can and will cause some audio artifact. It's not something that you want to do live. Hence why the multi-room concept, multiple environment makes sense, because, you know, changing it in an active room, talking here about the live scenario primarily, you know, wouldn't be ideal. This is not just a standard reverb. This is not just a stereo reverb. This is all loudspeakers, early reflection localized. You know, if you've been following the story of on our reverb, right? Early reflection localized, a cluster that is partially diffused, that can get localized, and then a tail that's completely diffused. And obviously, if you've got 64 speakers, yeah, you can imagine when you're doing major changes on the reverb engine, it can have some audio artifacts. So without further here, let me actually just switch the screen. And what we're going to do here is I'm actually going to go into SPAT. And I'm going to connect back with you guys in a quick second. Okay. Let's do that. Can you see me? Yeah, you should be able to see me. So here we are. We are actually in SPAT Revolution. I am inside the room. I chose one of those rooms there on top, and you'll see me work on that session all the way to the end. I just picked one room and actually chose the Reverb engine section. And the reason I wanted to show you the Reverb engine, well, is to talk about these presets. So here they are in the pull-down menu, various presets that have been, you know, ported over to the system, you know, being, you know, the Vienna concert hall, a cathedral, a football stadium, a small toilet, a stone corridor, some of the kind of the start points to give you an acoustic simulation. And now, obviously, you know, we've talked about the fact that we can start to save. So as we're going to be, you know, choosing an actual, you know, preset, and we'll start to modify it. You see the current preset has been modified. We can actually be able to tweak this preset and actually do a save as and actually make it, you know, the Hugo preset, for example, right? So quite simple there. We've got the new preset. Our new list is containing that Hugo preset. And as simple as this. Now, I talk about export and import. Well, they are right there. So export all, so exporting all the presets, or simply exporting the current preset, which I can export, opens me a little pop-up, which I can say Hugo preset. Et voilà. Then if I need to import it back in a project on a new session or another system, I can go import and simply choose that preset and go open and bring it back, right? Quite simply, there's no, not hours of conversation to have about this, but feel free if you have some questions, and you're curious about the acoustic simulation that's going on there. If you're looking at those parameters, if you haven't played with the software, if you're looking at those parameters, you'll actually see that some of the terms that we use are actually about perceptual factors or perceptual, and this is actually a long research at the IRCAM, if you've been following our conversation, where we're trying to add up some words that kind of, speak volume as and relates to how we perceive more than actually just plain reverb setting that sometimes are just, they're not abstract, but they're very scientific more than actually, just trying to translate this to a word that we understand. So anyway, but yeah, the reverb, the reverb engine, it's a big, important part of SPAT Revolution, this acoustic simulation. You're not obliged to use it on all sources. You're not obliged to use it in a source if you don't need it. But as you're starting to move distance of objects, right, this reverb engine comes and glue everything together. It brings a sense of reality. When you're in binaural, for example, it just, I like to say, it glues everything together. So that's our little kind of presentation on the reverb presets and how they're being managed. I don't think I'm forgetting anyway. There's a reverb button. You can reverb after a modification. Quite simply rename, save as, all things that we are fairly simple. Sorry for the squeak of the chairs. I don't know if it's bothering you, but it is bothering me anyway. Okay, so let me actually switch back to the other part of the presentation. If you have questions, as I was saying, feel free to ask them, and we'll cover them. My friends are actually live on the chat with me here, and they'll be pinging me in my ears, Hugo, and they'll, post the questions. Okay, let's just do this. Okay, now let's go and talk about this new panning method that's called dual band VBAP, or dual band vector-based panning, VBP. And what dual band VBAP is, it's basically like it is for VBAP and VBIP and all these vector-based or amplitude, angular style panning. Dual band is basically available for 2D and 3D arrangements. Works for both. And what it is basically, it is, kind of a hybrid of VBIP and VBAP. What the difference between VBAP and VBIP at the base, intensity versus amplitude panning. That's really the key point about those differences. And, the similarities has to do with the fact that VBAP implements it more from an energy-based perspective. Speaker energy is typically what we refer to. And what we have found with VBIP, and interesting, VBIP is actually some work, and I hope I give the credit properly on this one to the IRCAM, to the IRCAM specifically, and Jean-Marie Pernaud that worked on VBIP. And the results and what we've been finding is VBIP actually, appears to better localize content above 700 hertz, to perform better above 700. So we basically, if you kind of put the maths together, the dual VBAP opportunity here is to kind of take advantage of, using amplitude type panning under 700 hertz and the intensity, the VBIP style above. Right? So that's really what it is. For having played with this personally, they're very subtle. But I mean, from an intelligibility perspective, when you use VBIP against VBAP, for example, definitely something that happens on the vocal range, some of the intelligibility, and that's what I've personally experienced. It's fairly subtle. It's not like but that subtlety actually plays very nicely in refining something. So now with dual VBAP, you kind of get best of both worlds, if that makes any sense. The ref document here. So just to scroll back, my friends on the live webinar, I know if they've pushed, some of our older sessions. We've been doing the sessions. They're all available, by the way, online, and this one will be available. Offline, meaning not live to watch. But maybe Nicolas, you can actually push. I'll maybe send you the link. Can I send you the link on this? No, I can't send it to you. I don't know if you have the link, Nicolas, on either ResearchGate or something. Maybe you can push it. For people that are interested to understand a bit more about virtual sound sources, positioning and mixing, and VBAP, yeah, you will post it. Thank you, Nicolas. He's going to post you a link. You can download the PDF if you like to lead the, you just search the link. Yeah. Oh, there's the link, I'll actually gonna send it to you right away on the chat. Or, yeah, can I do this? I can probably do that. Hang with me 2 seconds, guys. You see? Boom, boom. There you've got my friend Nicolas. You saw me do this live. Not even a chance to switch the screen, so you saw it live. So he can post this to you guys. Yeah. Okay, so here we are. So this reference document, if you like to read about it. Obviously, and I cannot make you listen to this really, it's about presenting it more than anything. You will see it in the panning option as we get back into SPAT a bit later on. Now, just as we're starting to talk about, vector-based panning, and we've covered this in the speaker presentation, or the dealing with speaker arrangement presentation 2 weeks ago. But I wanted to kind of bring back some of those realities to the table. So, we are kind of in line, and that kind of helped me introduce some of the other panning methods. So, when we're dealing with vector-based panning, we are kind of constrained with some of the elements. For example, the listener needs to be inside what we call the convex all. Basically, you've got to be surrounding, the listener on these systems. You cannot use just a line of speakers, right? I talk about this here. A collinear system is not allowed. And collinear is something we'll talk about today. We'll be talking about WFS, so a line of speaker. So traditionally, you can't do, and I'm not going to go into the deep explanation. If we have time, maybe I'll kind of review what we did. But again, I recommend you guys to watch the speaker arrangement webinar we did on this specific one. But just to talk about the fact that, in vector-based typical panning, the collinear system would not be able to, to be used. And this is what we have for WFS. But yeah, back to some of those rules, right? In a 2D system, you're looking at a planar system. That's at the same elevation at the sources, and that's it. That's all. And again, surrounding the listener with speakers and with the convex all. And then when you're moving to a 3D, you're basically adding some speaker sources, with some elevation, creating another layer, multiple layer, creating these domes. I say above or below, right? Positive or negative elevations. Now, again, we've got to be respecting, but yeah, you're basically, again, just surrounding listener. It's the bubble around, right? As you're moving, to 3D systems. Now, I said on collinear system, you can't do vector-based. Well, there's some little tricks around that. We kind of covered it. You can actually put a phantom speaker, in the back, to pretend there's actually something and actually leave it muted, like a silent node, we could call it. So that is, kind of a little trick that I showed on this for people that want to use, for example, a vector-based amplitude panning on a collinear system, on a line of speakers. Little important thing here is no coincident speakers. What do we mean? We cannot, in these, vector-based panning, actually have in 2D another speakers at the same azimuth, so at the same angle. It's angular based, right? You cannot have two coincident. And if we're in 3D, same azimuth and elevation, right? Same concept. Little rules that we've applied there. And the reason I kind of wanted to talk about this is, I've introduced the concept of triangles. That's exactly what it is, if I get to go back in SPAT, you'll see, an image that kind of shows these triangles, right? Listener, the relationship listeners, to the speakers, in the system. But when you actually got a linear system, you have, you don't have the ability to have triangles everywhere. Maybe hard to follow as I'm not doing the full presentation, but that just brings me the triangle conversation, brings me to talk about the fact that when you are in 3D, we are starting to triangulate. Triangulation happening, meaning what? Meaning that, in vector-based panning, typically by default, two speakers, well, if you're on a speaker with a source, only that speaker is active. But as you move the source, you're basically going to be, panning over these two speakers, two active speakers, as you're moving, like pairwise panning. Between those two speakers. And that's fine. That's the 2D work. But as you're going to start to elevate the source, we're going to have what's called a triangulation, meaning a third speaker on the elevation will get picked up. And actually, will be used to localize what's happening, with your source element. Why do I want to talk about triangles today? It helped me introduce the next point, which is the point that has to do with the challenges of elevation. And the triangulation that's happening may actually not position your source exactly that you want. And mainly if you have an actual source that's moving with some elevation, that triangulation can actually be unstable a bit in some ways. And there's ways to stabilize that. And that brings us to talk about, well, the challenge of triangulation. And let me actually just get back into SPAT, and we'll kind of start to talk about this and then to introduce layer-based amplitude panning. Voila. Okay, everyone is doing good? I hope. I hope. Let me just prepare on the side. Make sure all is good before I fire something up. Yeah, I think it's looking good. Just 1 second. Voila. Okay, let me get back to you. Et voila, here I am back. Just want to make sure my face is actually not too much in the way. It is maybe just a tiny bit in the way. Let me just do a little modification so you guys can appreciate what's going on there. Okay, here we are. So we actually are right now in a room. And what I'm going to be showing to you is some of those challenges that's happening with your triangulation. I'll try to express this to you. I'm going to be using basically, there's a sine wave going on already on that channel, a -3 dB sine wave, and I'm going to be moving the source in just an azimuth, change over 20 seconds around the listener. And thanks to something that's called the nebula, which you will actually see. You see it right there. There's a little point. The nebula, it's basically us taking the energy of all the outputs and rendering this in a visual representation of where the signal is. So right now, our source is at default center, and we can see the little point right there, and you most probably can appreciate it right here. Let me increase this. Yeah, there's maybe the lightness is a bit too high. Yeah, exactly. I think that's going to be better. And I can remove some of the speaker alpha a bit. Okay, so you see that it's actually dead center right now. So we're going to be moving this source around. Right now, this source does not have any elevation. And what you see right now, if you actually are looking at this window here, we still have the signal right here. But you see that currently, the source is outputting only on one speaker, and that is simply, it's dead on that speaker. There's no elevation, there's no triangulation. It hasn't started moving. Now, let's see if that works. If I'm starting to move actually that source around, and you can follow what's going on with the little you're probably seeing that little visual nebula representation. And what you're basically seeing on the metering is that actual two-speaker active as you move around, as you're actually moving around the source, right? Quite simple. This is the base of a 2D layer. We're back to the 0 and only one output, exactly like we wanted. Now, what's going to happen if we start to elevate the source, right? So that's the question. So if I'm starting to actually elevate the source, you can actually start to see what's going on, and you see it on the right screen here, which is my my front view. You can see that we started to elevate. And if you want to appreciate what's going on from a system perspective in a triangulation, you see now that I've got 3 speakers active. And that is for the simple reason of the triangulation I was explaining. Right now, so you understand, we are on a Dolby Atmos 7.1.4 arrangement. And I'm going to be comparing 2 panning methods. I'm on that room that's called VBP, and it is a VBAP. Well, it's actually using the dual VBAP. Well, let's look at this. I'm basically playing with you guys on these 2 rooms here, that layer base and that VBAP. And if you look at the VBAP one, I'm actually using the dual VBAP, the dual band. Now you're not hearing it. Sorry for that. And would be I could actually virtualize this maybe. Maybe next time I try to do this. So here we are in the Atmos, system in VBAP triangulation. Now, If we actually start to rotate this source, I'm going to start to express to you, and you're hopefully going to be able to appreciate this visually. I'm going to start to send the source around, and I want you to watch what's going on with that little point as we move the source around. So this is the example of you've got a sound stage, or you're designing a mix. You've got a source that you wanted to elevate to the image, maybe matching to the image, whatever it is. You elevated the source, but this source is going to be moving. So what I want you to appreciate is how the triangulation may not be your best friend. For a static position, potentially, but if you're starting to move objects in this elevation, that may become a challenge. Let's see if what I just said here will do the trick. Yeah, can we see these instability? Well, you can clearly see some of the weird movements that are going on, you know, the kind of the skipping, you know, that I like to think. I'm going to elevate this source a bit more. You're probably going to be able to start to appreciate more as we go. Yeah, you actually saw it there a bit. Let me just spin this again to see at which elevation we can actually see, you know, what's going on. Yeah, so you saw what's going on with the source, right? As it's moving around, and that is basically as it starts to triangulate with the top speakers, it becomes unstable. You know, that's kind of the instability, you know, of such a system. Now, let me actually remove the elevation. We're back to zero. We're back dead center. We clearly see this there, and let me introduce you, you know, quickly our VBAP and the layer-based approach, which will be our alternative to this. And you guys may think, what's that? Layer-based amplitude planning, another acronym not to remember. Well, you guys will discover rapidly that, you know, you're actually probably not fully new to it, and I'll explain why. Okay, let me get back to you guys. Okay, with layer-based amplitude panning. That's a lot of words, right? Layer-based. What does it tell us? It tells us that we're going to be approaching the panning from a layer perspective, not trying to triangulate to begin with. Yeah, that's a little error. An hybrid of VBAP and VBAP. Yeah, that's just a copy and paste. Sorry for that. So basically, you know, what the layer-based amplitude panning is, it's actually all about, you know, spatializing, you know, sound in a 3D environment, but based on layers, as I was explaining. You know, as it is in a cube, for example, that's a good way to express in a cube, you know, because you've got, you know, 4 speakers at the bottom, 4 speaker on elevation. And basically, you know, we're talking here about the concept of crossfading, moving from this layer, whatever's going on from a panning perspective, to another panning up there. Really, that's how I like to talk about. It's the VBAP principle on layer, right? Layer 1, VBAP. You saw my 2 speaker active, but as I'm going to move up, I'm going to move to 2 active speakers as well, and you'll be able to visualize this in 2 seconds, right? Moving from 2 active to 2 active speakers. That's really what it is. No triangulation, none of that instability. And almost any sets of speakers can be used because we actually are, you know, are not. So, you know, there's more flexibility as well. Some of the rules that I was telling you are not applying to this without getting into the details. And why do I say you're not new to it? Well, quite simply, when you actually been, you know, panning in Dolby Panner, that's exactly what's happening. They're not triangulating. And obviously, because the guys in Dolby Atmos in the cinema world, for example, are doing a lot of movements, these triangulation would potentially create some misfiring or mislocalization. So the layer-based approach is actually what is used there, okay? And it brings that stability to objects when they are in movements. Okay, I hope this is making sense. Let me just actually get back to, you know, just no better way actually, you know, to show things when there's a visual representation. So where are we now? Now we were in this VBAP room, right? And for you to appreciate, I'm going to move the source just a tiny bit. And if you're looking on the left side, you saw the 2 speakers are active. And obviously, if I bring some elevation, you see the 3rd speaker. If you look at it from the output perspective, we looked at this. But now what I'm going to do is I'm going to move to another room, which using the layer-based amplitude panning, same object position. That's the ability that we have, right? These multi-room concept can be fed from all the same sources, so sharing the same position. This is the ability in SPAT to create various stream format in parallel, right? Creating a binaural world, creating an Atmos in parallel. So right now, that's what I'm doing. I'm going to move to this room. It's just called the layer-based amplitude panning, and look at what's happening here. This is our concept of the layer-based. Now, the signal on the bottom speakers, right? We haven't put much elevation, so speaker number 2 and 3 right now are actually, you know, at a different level, and that's because I'm in between. And then you can see the same thing happening on the above speaker as I've started to elevate. And if we actually, you know, kind of look at this live, you know, if I'm killing the elevation, you could see it maybe on the left side, and I'm starting to move the elevation, you will see the crossfade that's happening, and at one point, only those two, this layer will be active, right? Crossfading. Isn't that is that stable and clear? I hope so. I hope so. So let's try to reset 0 azimuth, 35-degree elevation, and let's see what this move does to us in actual LBAP. If it's working, yes. You see the movement from the top view. There's the little skipping you see is not the panning issue. It's just the nebula processing going on, doing a little glitch there. But you saw how, you know, very smooth it went all the way. I don't know if you saw this. I hope you did. I hope you did. Let me just tweak this nebula just a tiny bit. We can actually, so we're at 35 degree. We could go at 45 degree and continue that move. Obviously, at 45 degree, we'll have quite some stability. We're active only on the top speakers at this point. I can actually lower this to 20 degree, maybe. Let's lower it to 20 degree. Now we actually have got, yeah. But I don't know if you've compared it to what was going on before. If I actually jump to the VBAP room, you're most probably going to be seeing, you know, those instabilities come back. Let me just run it for you guys. Yeah, you saw it right away, right? Look at these fast little, you know, as you get closer to the elevation or between the elevation speakers, yeah. So you're really, really clearly seeing it, yeah. And on the right side, I just saw it. You saw the little shift. That's exactly what layer base does to you guys. Okay, yeah, yeah. Hope it makes sense. Hope it makes sense. Okay, where are we now? There we are. So we did that little VBAP and LBAP on Atmos system comparison. If you've got questions, again, feel free to ask them. And now we're going to be actually going into, yes. Oh, well, my brother likes to bring me some sheets. This way I can take a little break and take a sip of water. And I actually like to say hello to people that are online. So he brings me these leads. You know, so we've got Raphael in Vienna. Hello, Raphael. Raphael, I say hi to you every week. You again? Didn't I speak with you like 2 times or 3 times in the last week? I'm just kidding. But we've got visit from Germany, from Lithuania, from Germany again, Belfort, Des Moines, Iowa. Yeah, so there's some guys in the U.S. that are not on vacation at Thanksgiving. You know, I guess they asked their permission to the wife to get online to actually watch this webinar. Thank you for being here. Romain from Paris, Christopher from Michigan again. Oh, Wanzo Productions. Hello. Those guys are actually late in the middle of the night. Yes, Wenzo is there as well. Yeah. And we've got a long list of people. The Dojo. Oh, the Dojo. Upstate New York is actually there. Hey, my friend. Josh at the Dojo, which been doing some meditation, immersive meditation, using SPAT and binaural technology. We've got a little video on that one. Thanks for being online, guys. You know, Gail has been answering some questions. That was a piece of music in LBAP bounce, speaker configuration. Yeah, I'm assuming that those are being answered online, and we'll be, we'll be covering them in the Q&A question. So now let's dive into our wave fill synthesis conversation. Indeed. Now, some people are probably looking at us, hey, those guys are crazy. You know, an actual WFS system only on the frontal speaker, a system of 7 speakers. Why is that? And let's talk about this today. And what basically we have here is what we call a relaxed wave fill synthesis. Wave fill synthesis is known for needing a large quantity of speakers. Some numbers may be, a minimum of 32 speakers in the line, all space at 20 centimeter as a minimum. and a minimum even to create what we call the focus effect, which you'll see in the images as I move back to, to SPAT a bit later on. But basically what we've got here is we kind of, taking a relaxed approach to WFS, providing a solution for wave field synthesis on a frontal system of 6, 7, 8, 9. The more the better, obviously, but you can actually go to these compromise. So instead of having a frontal system that is based on the angular method, which is very sweet spot centric, that basically comes and bring an alternative to using angular panning. And what's interesting in all this is from our field work, you probably saw the video from our friend Johnny. If Johnny's online, I can say hello to him. Johnny Torchy. We actually thought about inviting him on the webinar, but he's French speaking. It would have been needed a translation maybe, but yeah, so Johnny, actually did, this exercise of, moving to WFS on only, a limited amount of speakers, which were, I think my memory is correct, about 2 meters, so 7 speakers at 2 meters. And the result, from a live show was simple, that it renders better than using the traditional sweet spot centric. So why not go for this relaxed method? Okay, that's really kind of the concept behind it. Now, WFS is a 2D only system. So you can't really do elevation. And if you want to start to spin around stuff, it's a frontal system. It's a collinear front system. There's ways that we can do things with the multi-room concept. For example, we'll look at it at the end, how we can actually have another room to handle the rest of our speaker, the rest of the bubble, the elevation around it, while having a frontal system in WFS, okay? But yeah, so, and in the wave field synthesis that we're talking here, we're talking about the point source approach and the focus approach of wave field synthesis. Now, focus zone, let's be honest with each other here, unless you have a large quantity, and that's not 7, the effect in the focus zone will be, either just not there at all or kind of weird or not working. So we're not promoting the concept of focus zone, which is the near field. You may have seen some of those wave field synthesis presentation talking about bringing a sound to someone's ears, right? And the focus, the near field effect. And this is not something that can be done on a small amount on this relaxed version. Quite simple, okay? Hope that's clear to everyone there. You'll be seeing that focus zone in red when actually going to move to the screen a bit later on. So hope this makes sense. So, what are we talking here? As we're talking about WFS, well, you've seen this image. You've seen this image in the video from, from Johnny. You have seen similar images, even from a frontal system in traditional panning. The problem with stereo, I think I don't need to cover this. We know about what it is. There's a small sweet spot zone that really gets immersed between those two, right? This was discussed enough. And I love this one. I picked it up. I stole it from AES France or maybe Radio France, but, it's kind of, taking the first one, the one I just showed you, but talking about how everyone can be happy on a system using a frontal WFS, with these little smiley faces. And some non-smiley face on the stereo. But yeah, we're beyond that. So what we're talking in the WFS is the fact that we're synthesizing, we're replicating the actual wavefront of a source where that's virtually placed in our software, right? But we're taking the wavefronts of that source and using all these line elements to recreate those wavefronts. And you can actually start to appreciate this from the image on the right side here, right? It's basically got, elements in the space and their wavefronts are being reproduced. Reproduce how? Well, we'll talk about this, So what's WFS, in a nutshell, and today is not the plan to educate everyone on everything and all the theories behind WFS. We're basically talking about a special audio rendering technique, right? Where, as I was saying, you're positioning sources virtual, right? They're virtual in a virtual space, in the real space. Basically, it's a reproduction system to kind of recreate the wavefront of all those elements, okay? Of all of these objects. Your object mix, object in the space, we're the synthesis of that reproduces it. That's basically what it is. And it breaks that sweet spot limitation of traditional multi-channel audio systems that we talk about. Now, important to understand, it plays with amplitude, but it plays with phase, with delay, and some filtering. Yeah? It's a complex technology, which means what? It means that you can't just do whatever. You know, for example, you would not want to move a source very fast. If you're looking for fast movements in something, you'll definitely apply other panning techniques. You know, I like to say that, you know, this, you know, can work for some small movements, but it's actually very useful for more a static scene, you know. One song, there's a scene of a song, you're reproducing symphonic orchestra, reproducing that, you know, that image, you know, with a front of speakers. But that's what the concept is all about, okay? And that's another image that kind of talks about you know, this concept there, you know, with some colors, you know, how, you know, we've got, you know, elementary wave, you know, that's being fired, you know, versus via that loudspeaker array, okay? So it's a synthesized wavefront. That's what it is, okay? Good. Now, as I was saying, some considerations, you know, and things to know about WFS, you know, source is always at the source is always at time 0 for the closest speaker. So, you know, wherever you're putting the source, the closest speaker is time 0, the other are being delayed too. One thing to know. Now, one thing that I actually discovered yesterday, you know, we always learn things, is that, and it was measured, so I hope what I'm saying is actually true, but I think it's true because Nicolas validated this, is when you actually put a source straight on the line of speakers, it actually behaves like traditional amplitude panning. For someone that could say, hey, for my vocal, I do not want some of that effect. Well, putting that source straight on the line of speakers would actually make it act like an amplitude panning, a traditional amplitude panning. Kind of very interesting, something that we'll explore a bit more, but yes, source on the line, there basically nothing applies. It's as you're starting to move some distance, okay? And as I said, you know, watching for moving sources as it will bring some timbre and audio artifacts, that's for sure. So if you're planning to do, you know, some spinning around stuff, keep this stuff in another room. Keep source in another room. And then you can mix strategies again, back to this multi-room concept, okay? So now, let's just, you know, actually, let me just, 1 second. What I'm going to do here is this. Yeah, this way I don't ruin the image. So that was the, you know, the video that you saw, right, on the Necolite Orchestra project. And just kind of briefly to go over this, you've seen this, but this was, you know, reproducing, you know, those wavefront with 7 clusters of Cara, small ang of speaker, fairly nice size venue, and, you know, some stacks of, you know, 2 Kiva were on the floor to kind of, for use as a front fill system. You know, SPAT was basically driving this Dante over to some Dante breakout boxes, feeding the LA racks from L Acoustic in this particular setup. And you see, you kind of saw here what's been going on, right? It's the object-based concept. You're not, the console's not doing the summation, right? You're sending these objects, these sources into, you know, SPAT Revolution, in a WFS room, you're positioning the sources, and then, boom, it's going out. And in this case, they were spinning it out in Dante, then breaked out to AES, EBU for outputs to these different elements. Now, let's dig in. What time is it? 12:52. Got some questions here, but I'm gonna come back on this right after. So let's actually move to SPAT, and because we were able to start to appreciate, and I'm gonna go over a few things here for you. So let me just connect here for a quick second. Up, 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 up. And we're doing you know, fairly good on time, so I'll be actually able to up. Voila. Okay, here I am back to you. So here I am actually in these. I'm actually here on back on this demo session, and this was something I kind of started to do part of the dealer speaker management, a speaker arrangement presentation. And this image was basically showing a collinear system. And collinear is what we're talking about here with wave fill synthesis, and how you wouldn't be able to use the vector-based type amplitude panning because, well, back to those triangles, if I actually move a source, well, there's no triangles here, right? You see those triangles, you know, and that's kind of the base, you know, the listener the listener is not surrounded by speakers. He's not inside the convecle. So that's just a no-go. Now, there's a way around this, to actually kind of, take care of this. And that would be, using a phantom speakers. And you kind of actually see this right there. And that's the concept of collinear. But now really collinear, the concept of using collinear would be, the WFS approach. And you basically, have an idea. Let me just go back to a single, oops, I can do this, Hugo. You can, yes, you can. Voila. So here we have a little image, and what you have in the blue zone is what I call the safe zone, right? And this is basically, I'm just looking at an overlay. This is something we're actually finalizing right now. This is just me doing an overlay. We're kind of making this a bit prettier now, but that's just kind of really to show you what's going on. So here we are on a system of a front of 8 speakers. We've got what we call, the safe zone. This is the zone, the secure zone to put actually objects to actually get the wave field synthesis approach working. And then you actually can appreciate the focus zone, the zone in between the listener. And I say the listener. Now you say, Hugo, wave field synthesis does not have a concept of a listener. Well, there's a zone, there's an audience zone. So see this as the audience zone. So the in-between, basically in front of the line of speaker, is what we consider the focus zone. And as I said, and it's in red here, this is not something that would work in a 7-array system. Now, it could work on a larger system. I'm presenting today wave field synthesis on a relaxed version for live production for a smaller system. Obviously, I haven't tested, but I'm assuming that we can do 50 speakers or 64 speakers in the line, and that would just work fine. And then you would gain back, following some of the restrictions, gain back that focus, that near field effect, okay? And as you can appreciate, as I'm moving the source here, if you're actually looking on the left side, all speakers are collaborating. And as our friend Nicolas was, came yesterday, and if I'm actually plugging this closer to here, well, there you are. If the speaker is right on the actual, if the source is right on the speaker, only a single active. Anyway, I'll have to validate this with the team there. But anyway, the point was not that. The point is the closest speaker will be reference 0, and everything will get delayed, giving basically, a non-sweet spot-centric delivery to the room. I'm doing this here, back here, on 7 Meyer MM4 speakers, spaced at, don't remember, I've got a total line of 2 meter, mixed position is at 1.5, and I'm telling you, it's just beautiful. You don't want to go anything else than that, if you obviously can afford to have 7 frontal systems, speakers. But as you can see, all speakers are collaborating to deliver this, so it's not only that person sitting on the left side of the stage that's getting an experience, but it's everyone, right? That's the concept of it. Now, if we're actually moving to this particular one, now we're actually, I'm zooming out. And why am I zooming out? And I'm going to be scaling stuff. And now I'm starting to look at the system that is, closer to real world size. We have here on this arrangement speakers that are, at the 15-meter spread totally, so like a 45-meter stage, and they are at 10-meter. So basically, 10-meter in the front. So 30-something, 35 feet for the Imperial friends here. And that's kind of me putting, that listener at the center of my audience zone, right? Just, as a reference, okay? So we've got this, you see the safe zone here. Again, we've got this focus zone that could probably do something. I haven't tried it because, I'm not expecting it to work anyway. Right, so we've got this safe zone and signals going on. And that is basically, exactly what is needed. And that is available as soon as you basically, are, going into a room. You now have the option to choose WFS conditional to having a speaker arrangement. And we've pre-created frontal line 5, frontal line 7, frontal line 11. So we've got 3 new frontal arrangements that are predefined for you. You can obviously modify them, but as we have new speaker transform options and ways to create speaker arrangements on the fly, you don't even need to take this. You can create your system very rapidly. Let me just show it to you because I like to think it's cool. But, if you actually wanted to create, a new arrangement, we could just create a new arrangement, call it my WFS, and then add some speakers. And we have the ability to say, hey, how many speakers in the linear line, in the line on the x-axis, so on the front, in this particular case. And what's the distance? You know, my audience zones is 15 meter from the actual, you know, line of speakers. I want a spacing of 2.5 meter in between. Apply. And it did not work, or it did work. Yes, it did work because it's further away. Can you see it? Yeah. So we've got our line of speakers done. Okay. So this is a new, you know, a freshly created WFS conversation here, which should work. Yes. Okay. Now, did I? Yeah, I did change it, and I did not want to do this. Yep. Just a quick second. I'll get back to what I was. There we are. Okay. So back to this, you know, this system, and that's it. That's all what's needed, really. There's no extra steps of configuration. As soon as there's a collinear system, a line of speakers on the x-axis, it can work. Now, you may want to be asking me, Hugo, what are we going to do for speakers on the sides and on the rear, you know, in my theater, in my shoebox? Or, you know, what am I going to do if I want to add some elevation? You told me it's only 2D. Well, we're going to start to talk about some of the use case, and we'll start to talk about how to manage subwoofers, because yeah, the famous sub question. I'm not going to go fully into subs today, you know, and if there's some system techs out there, you know, that are listening, they'll, you know, they'll want to kill me and pick up a long conversation, because subs is always a long conversation. But let me just actually get back to this slideshow here and start to talk about some of the case and conversations. So, you know, how would we deal, you know, so I basically been saying, you know, it's a frontal system. So now someone could say, you know, and we're exploring those cases right now. And to give you some ideas, we're still reflecting on them and how to better present them. But, you know, one of the fact that we have multi-room concept, if I add basically, you know, 4 walls, a wall in the front, but I add a side wall of speakers here and a side wall here in my venue and a rear one, well, although you're limited to putting the arrangement in the front, nothing prevents you from spinning the head. I didn't even show this yet, right? But in SPAT, you have the ability to move the head around. So basically, you could still do a frontal system, but rotate the head, in each of the rooms. So that would be kind of a concept of using multiple rooms to handle your frontal systems and maybe your sides and your rear. So with 4 rooms in WFS, 4 walls, spinning the head. So heads listening from a front perspective, side, rear, and so on and so forth. That would give you, you know, potentially exactly what we want. So that's something that we're exploring. And now, if you needed to add those speakers in surround and VBAP, and I'm going to wrap up at the end and show you this, is you could actually use 2 rooms or potentially even 3 rooms. One would be for your frontal WFS. One would be for all your surround speakers. Okay, so the rest, elevation or not, maybe just a 2D, and I'll wrap up with this. And then maybe even a third one with an angular panning, and maybe a third one only for your reverb engine, something I was discussing this morning with the team. You know, could this only for your reverb engine, for example. Hope that makes sense. Obviously, it opens a lot of conversations. We'll be coming back with specific, you know, documentation, tools. We're trying to make it as simple as possible, as you can see, or as approachable as possible and ergonomic in the way that we present it. But for now, you know, you add the speaker arrangement on the fly. You give the dimensions, the spacing of your line of speakers. And if it's a line of speaker, wave fill synthesis becomes available as an option. You don't like it, you go back to VBAP traditional panning, adding the phantom speaker, or you choose DBAP, or you choose KNN or another of our approaches, and that's it. That's all. You can rapidly compare system. And I'm actually you're gonna see this. Now, yeah. Now let's talk about subs. The famous conversation of subs, and funny enough, I've called my Johnny, who had experience, WFS yesterday, and asked him the question about subs, and about how to align your subs into this whole equation, right? Because that's obviously an important part of a system. And then, one of the first things that came up in the conversation is, hey, Hugo, I typically do a mono sub cluster on the show. Is it fun to actually align to the left, right? Stack? Well, it's always the same problem. The problem starts already in stereo. You align the sub for in the room, right? So the challenges of aligning sub remains, and actually is maybe different because you have a line of speakers and you can maybe rely on a single speaker to align to, and that's what actually he did. And I'll talk about this a bit. But really, what I wanted to say about the sub is we have the ability in the WFS room currently, unless we decide to remove it, but to add a 0.1, to add, we're not going to remove it, about a part to add a 0.1. Okay, so the 0.1 is something we do on any speaker arrangement as soon as you add a LFE or a sub speaker. Name LFE, LFE1, LFE2, LFE3, or sub. Basically, these speakers are fed from a Knox sen, right? LFE approach. Now, the LFE approach, is like aux on sub, and as a mixing guy myself in the past, I was never a big fan, but I'm not against anyone that like that concept, and depending what you're trying to do, LFE makes a lot of sense. Now, it's maybe not ideal because we have to take into consideration that obviously that send has no delay, no time, it's not aligned to that particular source that you're sending, right? So yeah, you got to start to reflect on that aspect, but LFE can be used and is possible. Now, typically, when I'm looking at the systems, and then the conversation becomes about systems and system specific. So I'm not going to make it too big. But we have the reality that when you're flying some speakers, or sometimes have too small speakers that can't reproduce low frequency, and you have seen the concept of low frequency extension, right? Flying subs with the top boxes, top maximum coherence, they're all together, a lot of low frequency happening up there. And this would obviously be a favorite way for me approaching a 7 ang in the front, all tightly together. Now, that doesn't mean, that doesn't mean that we can't use some subs on the floor. And obviously, we're going to say be careful with overlapping frequency, as we've seen in the latest later years, or in the latest years. As we've seen on systems, a lot of systems are actually doing quite a bit of overlap, right? The infra actually overlap with the top elements, being a top or a top sub flown. There's a lot of overlap. We're going to be watching for this as we're doing this. But if you are being careful, with these overlapping systems, obviously the infra sub can be your place where you're going to be summing maybe a single box, just sending a single of those 7, but potentially sending the 7. Now, I was not convinced about sending the 7 down to one box, but it's actually exactly what happened to Johnny when they deployed it. They basically had sent the 7 sources down to the infra, obviously just for the low frequency extension of sources that add that content. And the alignment was done of that mono sub block to the center, which is exactly where, the kick, I think, was on his mix or not. I don't remember. But the point is that, you can use the infra subs as your, the place where you're going to be summing some of these top speakers content as an alternative. And now it's maybe triggering questions to you guys if you are a system techs, like, okay, but what about in this scenario? Yeah, the conversation on sub is a fun one, is a long one. It's the toughest one, but yes, there's various strategies to approach subs on these systems. Before to get to the Q&A, actually, I'm going to be going back to the little presentation. We're just on the hour 7. Yeah, I'm like 2 minutes, 3 minutes over. I just want to kind of have you appreciate the one last thing, and then we'll go with the questions. Yes. So we're back to this wave fill synthesis system here, which we add 15 meter across at that 10 meter. But then, you'll say, Hugo, okay, you've got, the source here, but you want to add some extra speakers. And as I was telling you, a source can be connected to 2 rooms. And here we are in a second room. Sorry for this. Here we are in a second room. Let me add some speaker alpha. Not needing the nebula. I think you can see this properly. So here we are in a second room, which basically, have, our complete speaker arrangement. So all the side speakers, the side wall, and even if it was a rake in a theater, to me, I consider this a single plane, right? People are sitting like this, speakers are angled like this. It's a line of speakers on the side walls, right? So there's no elevation. We approach these systems as 2D systems anyway. We got side speakers, we got rear speakers in a shoebox, and a cinema, for that matter of fact, could be as well. So here we are having a complete speaker arrangement. And what we're actually we'll be using on this particular one, what we're going to be using on this particular one is, a traditional angular panning or a VBAP panning, for that matter of fact, with bait sands or VBAP or dual VBAP that we've looked at today, whatever it is. But the point is, well, I should be seeing, no, I'm like, Hugo, you're not seeing output. Yeah, well, I'm not seeing output. Why is this, Hugo? What I actually have done on this particular one is these frontal speakers on that VBAP, I've actually muted, right? And they're actually muted in my setup. So basically, I'm not getting the VBAP result in the front. Why? Because my little friend here, the WFS, is handling this. And then, we'll finish this with summation. So in here, I can actually have, as I move the source, and it's the same position on both rooms, as I move the source, nothing is happening in VBAP, it's happening in the WFS. But as I'm gonna start to kick and move around here, and sorry if it's not in order, that was me doing a speaker arrangement too fast, but it's basically going to be doing our angular vector-based panning around the house. Okay, as simple as this. And as I reach the frontal zone, which is covered by the WFS, signal is gone from the WFS. Now, Hugo, how do you route this all back? Thanks to our system that's called, I did not do it there, but we could do this very quick. Thanks to the ability in SPAT to connect actually two rooms together and have summation happen. So if you're actually going to appreciate the speakers, is that going to be working? Yeah, it's going to be working. So right now, if you're looking, right, only my frontal speakers are active. I haven't moved the source around. And if I start to move, right, the source in this section, well, what you're going to be seeing here is, maybe I did something wrong. It's right there. Anyway, yeah, you're maybe not seeing it, but whatever. It's maybe my patching. But the point is that you're going to be summing these two into a single stream of the total amount of speakers. Yeah, it's my my preview on the view. But all these speakers, actually, which are part of the system, are being basically all summed together for a single output, right? So it's just simplifying the routing, and this becomes your discrete channels of the, what do we have? 7 fronts plus everything. A total of 29 speakers on this arrangement. Yay! Voila! Voila, 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 voila. Well, I think we are pretty much going to need to wrap this. It's been, the session is just 1 hour. We're pretty much on it, and I'm sure there's tons of questions. And I'm not always the most brilliant one. Some people may ask questions, and I'll rely on my friend Nicolas, or Gael, or Jean-Loup, or Arsène, or someone in the team. So we have Marlon Schumacher. Hello, Marlon. What are the restrictions on the loudspeaker setup for layer base? How many layer can there be, i.e., if it is not exactly geometrically in layers? Some algorithm groups to speakers into layers. Okay. Nicolas, maybe you can help me. I'm tired a bit. That's maybe why. How many layers can there be? Well, there's no limitation as far as how many layers. That's number one. If that answers this question, if it is not exactly geometrically in layers. Well, that's the famous questions of, when you do elevation. And I like to comment, and I'm not sure it's going to answer exactly your question, but, not because I have 1 or 2 speakers that are higher in my system that I'm going to consider them as an elevation. Why? Well, exactly because of the triangulation issues. And the fact that, are these speakers really going to make everyone feel like it's elevation? And the answer often is no, if they're not high enough and if there's enough speaker, right? When you're thinking about putting some layers around people, you want to have a system that covers your complete audience. If you're barely covering the audience and there'll be some weird triangulation, it's going to be a disaster. Now, the layer-based approach would help kind of, work with this. First of all, it does not have all these requirements that we would have from a system that triangulates. Number one. Number two, well, you're gonna kind of, as soon as you start to elevate your source, even if geometrically your system is not perfect, well, it will try its best on 2 active speaker at least. So you're not going to have some weird triangulation as you move a source here, and then because there's only one speaker. I don't know if you get what I mean. I hope I'm understanding this. Some algorithm groups the speakers in 2 layers. I'm not sure I understand that, Nicolas, if you can help me. I'm going to go on the second question. We'll come back on this. Not sure about the last question, Marlon. Hope I answered as much as I could there. Christopher, and we can continue conversation offline, guys, if you're interested. Christopher Plummer, has any research has been done on the impact of this WFS solution on the max SPL output of speaker needed? Seems that it should decrease the needed headroom for each speakers. Nicolas, did you want to say something? I have to put them in the same. Not sure if Nicolas is answering me. We've got a 10-second delay about. Well, actually, Nicolas, are you on my ears? I don't think you're in my ears. Okay. I think I understood the question. So sorry, Christopher. We'll go back to Marlon's question about some algorithm groups the speakers in 2 layers. Yeah, Nicolas in my ears. So the question on these, so there's no algorithms for groups of speakers, so you basically have to put them on the same elevation, right, if you want this to work. So sorry, I did not understand the questions. So 2 speakers are considered as a layer when they are on the same elevation. So, yeah, but it's kind of brings back to what I was saying, not because there's 1 meter difference on those 2 speakers because you were limited by your physical arrangement because there's something in the way that you necessarily want to consider them as an elevation speakers. If they don't really going to bring some elevation feeling for your audience, it doesn't make sense even from the mixing, from the panning engine anyway, to consider them as an elevated element. So, layering this because there's no groups per se. Yeah, very good question. Now that I understand the question, it took me a while. I went to bed late last night. It's Nicolas' fault. He makes me work like crazy. He's laughing. You got to see his face there. He's not talking. You can unmute your speaker. I can listen to you. Can you help me answer the question of Christopher here? Has any research been done on the impact of this WFS solution on the max SPL output of speakers needed? Yeah, you can tell it to me in French. I might be gonna answer. I'm gonna, s'il vous plaît, je parle français. No one is listening to you, by the way. You're only in my ears. So sorry, everyone. I'm having a private chat with Nicolas. He's talking on my ears, in my ears. I could put him online, but I was not ready for it, so I don't want to mess up the stream. And we're gonna be wrapping this anyway. So, qu'est-ce que tu disais? What are you saying? Plus que d'eau-parleur. Yeah. Yes. Yeah, so the level basically saying that obviously the level of each speakers will be lower as you actually add speakers in the equation. And not sure it's exactly, but let's pick this up for a conversation because, I want to make sure that we answer you properly, Christopher. And time is flying. So I don't know if we have other questions that have come up. If it's available offline? Yeah. So basically the question, is this available offline? Yes, as we're going to be closing, this session, maybe in an hour, it'll be available to watch again. I know I speak fast. And I know, I get excited on the subject. So, but I hope that actually, kind of help you guys understand some of these new features, that we've been working on. Again, thanks for joining wherever you are sitting in the world. Just to wrap up, so there's not only this presentation, these 4 presentations are available. You can combine today's presentation with the dealing with speaker arrangements that give you a complete view, or a bit more complete view on all this. And then get ready our friend's going to be posting right now the December 3rd session, OSC refactoring and ADM OSC support. The link to this one, so you guys can subscribe to the YouTube to get notified. We're probably going to be sending an email blast anyway to let you know that this one is coming up. Same time, same hour. It's going to be the last one. It's going to be a pact of, that's for the geeks, the guys that like about OSC's messages, you know, and understanding what's going on and, you know, basically, transforming and, you know, using a different grammar and scaling some information. And yeah, we've done quite a bit there, quite exciting. And the ADM OSC, you know, which is about an industry initiative for live production to kind of all talk the same language when we're talking about position and not do all our little things in our little bubble. And then your creation becomes specific to some hardware or some systems and not agnostic in some way. I like to use the word agnostic. And that will be what we're going to be covering on December 3rd session. So if there's no more questions coming in, I'm going to be kind of wrapping this up. I'm going to fire to you the video presentation again that we did at the beginning. So if you missed at the beginning, you can watch it. It's the story of Johnny Torchi, which we've talked about on the WFS system today. And are we good, Nicolas? We're good. Thanks, everyone, again. Thank you for the moderator, Nicolas, Arsène, Jean-Luc, Gael, Felix, whomever is online from the team. Vincent. Oh, Vincent, sorry, man. I forgot you. Vincent, our lead support guy, which if you've been dealing with us, Vincent is often the guy that, that looks over the support, the major support requests. So thank you for being online, Vincent. Say that? Oh, Florian. Well, you see, I'm going to get the list of all the staff, the developers. Florian is online. Who knows? Maybe Lorcan and Maxence. Yeah, but thank you. The Flux team, the Flux Immersive team, is all behind and following and moderating and listening to what's been going on. So again, thank you for everyone. I didn't even introduce myself. My name was Hugo Larin. Normally I do it, but I skipped it. From the Flux Immersive Consulting Group and Flux Immersive, leading applications and, being the evangelist for this beautiful product that I'm so proud to be a part of. And yeah, I was streaming live from our studio in Montreal, where I am located. And that's it for today. Hope you guys have a great end of day. Stay warm. I actually wanted to send you a video probably of all the snow that I've been getting in Montreal, but stay warm, stay healthy, obviously, in this crazy world. Thanksgiving, guys, in the US. Yes, enjoy the turkey, enjoy the whatever you're going to be eating and all the gifts. And the rest of the world will keep working in the meantime as you guys celebrate. So again, thanks for everyone. Have a great day. Join us next week, and it will be a pleasure to chat again. Cheers, cheers. And let's go with listening to our friend Johnny on the story of WFS again. Cheers.
The Neko Light Orchestra, the musical collective, had the idea of doing a marathon. The Neko Light project is really interesting because there are so many musicians on stage, up to 13. So the goal was to recreate the musicians' stage positions to give a sense of depth of field, which is really difficult to do on a stereo system as we can't get the sensation of distance from the source, though there are some ways that all the sound engineers will know. I wanted to work in immersive, but we could go one better and use WFS. I had no idea that it would be possible. For me, it was almost utopian. So we still had to define the number of sound sources that were going to enable us to do real WFS. As those who are interested in this technology will know, you need a certain number of speakers in order to create a credible experience. So we tried using 7 sources. Perhaps more would have been better, but nevertheless, it worked. I was confident from the offset. I even went out and bought the speakers in the week as I wanted to reproduce the experience and prepare the way ahead. Regarding the sound system, I used Karas in 7 clusters of 4 attached to a bridge in front of the stage, as well as Kivas in 7 stacks of 2 stacked on the stage. The Kiva stacks, of course, were on the same axes as the Kara clusters. For the mics and consoles, I used 2 Rio 3224Ds, a patch with 60 ins and a CL5. The appeal of the CL5, of course, being the Dante network, which allows us to interface the SPAT Revolution on the MacBook Pro with a virtual Dante sound card. Using the direct outs, I sent nearly all the sources to the SPAT Revolution, excluding the more complex instruments that require several mics, such as the piano, the harp, or even the strings, on which I always have a DPA and a pickup. So the SPAT Revolution was receiving 50 audio channels, with SPAT's WFS audio engine itself generating 7 more that were attributed to each of the Cara clusters or Kiva stacks. The audio paths of the Dante and the SPAT Revolution passed through the Rio and hit the LA racks in AES. The appeal of the SPAT Revolution is to recreate a dimension. It's capable of generating a space, and in particular, the reverb linked to that space. This is something we can't do in a traditional concert with more standard tools. The concept is compatible with several audio interfaces. It works with Mac's core audio engine, so we can plug that into whatever we like, be it Dante, DigiGrid, or whatever. So we can install a small setup with ease. In about an hour, we can do what we want. I'm not suggesting that we can easily exhaust all of its possibilities, because obviously there are many parameters, but still, after 1 hour, we can create a setup that works. I have to say, I couldn't believe it. Straight away, the sensation is incredible, because we can make the sound sources all but disappear. Obviously, we're used to hearing the sound coming from the speakers, which is still the case, of course. This isn't magic. However, the speakers themselves disappear behind the sound field, that famous synthesized sound field. It's no longer the console doing the mixing or the summation, it's the SPAT. And the SPAT doesn't just do left-right summation, the SPAT does a virtual summation in a virtual space. Perhaps it's that gives so much naturalness to the sources. That's the goal, in fact, to ensure that people are moved by the artist's emotions, and above all, to ensure that instead of having 15 or 20% of the audience in the centre with good seats, you know what it's like. Here, I was walking about earlier, and I'm almost tempted to say that we have 100%. Perhaps I'm exaggerating a little to say that 100% of the audience zone is good, but I really have the impression that we're able to respect the image that we want to portray, no matter where we are, both in terms of depth and breadth. And that's really incredible, because I don't know of anything else that would be capable of doing that on such a large audience zone. So after all these hours of work, what I felt in the Flux studios, or at home even, I also felt here. Better even, inevitably. We don't have the same sound system. It's just incredible. I think that we go beyond that which we can do with stereo, or other known systems. We go way beyond. It's gonna be tough to go back.